Good day, Algebra. We kick off Unit 6 with a lot of definitions. This is a unit that introduces some new concepts and some new terms, and we are going to start with those today. Monomial, okay? Binomial, trinomial, polynomial. You see they all end in that omial, all right? So what we have to focus in on is the prefix here. Who knows what the prefix mono means? One, okay? So a monomial is a mathematical expression with one term. Now, you think back to PO10 in algebra, we talked about terms and combining like terms, and we've taken mathematical expressions and verbalized terms before. So we've talked about terms. Now we're going to actually kind of look a little bit deeper. So a term is a number or variable or exponents that are connected by multiplication. A number, variable, exponents connected by multiplication. So an example of a term is just something like 7n. Okay? We've got 7 times n. They're connected by multiplying. That would be an example of a term. Another example would be negative 3x squared. Negative 3x squared. Another example might be 1/2 n cubed x z. All right? Any combination of multiplying numbers, variables, powers, all terms. You can have a term of just a constant, 7. That's a term also. Okay? How about the prefix by? What does the prefix by mean? 2. So the definition would be a mathematical expression with 2 terms. A mathematical expression with 2 terms. Have you ever seen a 1976 quarter? Anyone ever seen a 1976 quarter? Yes, you have? Yeah, it's got the drummer on the back, and it actually says 1776 and 1976 on the front. You know what I'm talking about? Anyway, that was a special quarter that came out in 1976 to celebrate our bicentennial, okay, our 200th anniversary of being a country. A little coin knowledge for you there, right? Give an example of a binomial, 2-termed expression. Anyone know what separates terms? Like what separates one term from another? Let's start there. Yeah. Addition or subtraction, okay? So something like 3x plus 1 would be a 2-termed expression. You have 3x, you've got 1, and they're separated by that addition. Okay? Daniel?
Does that mean that if you have something in parentheses, like if you have 7 parentheses x plus 3 close parentheses, is that count as positive?
Yeah, so Daniel brings up, he's saying if you've got something like 7 times x plus 3, because you kind of have both things going on here, right? We're multiplying 7 and x plus 3, which would mean it's 1 term, but then we're adding within the parentheses, which means it's 2 terms. How do we handle that? Before we can classify something truly, we have to simplify. So in this case, to simplify this, we would distribute that 7 into the parentheses, and we would get 7x plus 21, which would be a binomial, right? Which brings me to a good point. What came up in the last class, someone suggested something like 4n plus 6n. What's true about those terms? That means we can simplify them, yeah. They share a variable to the same power. So 4n plus 6n is actually 10n, so that expression would be a monomial, right? We have to have something else here. So if I added 10n plus 2y, well, now that they're different variables, they're not like terms, they can't be combined, so that would be a binomial. Even something like this, if you have 2x cubed plus 6x squared. Same variable, but different power. So they would not be like terms, they could not be combined, and therefore it would be a binomial expression. Like, gotcha? Follow me? Is this kind of review or is this new? Finally, March 1st, and I give you something you haven't had before. This is good stuff. Okay? What does the prefix tri mean? 3, trimester, tricycle, right? So it's an expression with 3, whoops, there's an R in 3. 3 terms. For example, who would like to give us one? Yeah. 2x plus 3y plus 7z, that is correct. All three variables are different, not like terms, can't be combined. Trinomial. Another example. I'll give you one. How about 10x to the 7th minus 12x to the 4th plus x? Same variable, but different powers, therefore can't be combined. Trinomial. Any others? Yeah. What's your favorite one?
Does a number have to have a variable?
No. So if we had something like 4n plus 2y plus 8, that'd be fine too. That 8 would be a term by itself and can't be combined with any of the others. Yes, Bridget.
All of these you can't combine.
Right. None of these expressions here can be combined because none of them have like terms, meaning same variable to the same power. Okay, to the same power. After 3, mathematicians get kind of lazy with their naming, and everything else is just poly, because what does poly mean? Multiple or many. You've played the game Monopoly before? Mono, poly. You want to be the one who owns many, right? That's where the name of that game comes from there. So a polynomial is an expression with 4 plus terms, right? 4 or more terms, all lumped together as a polynomial. So some examples might be negative 8n cubed plus 2n squared minus n minus 4. Okay? All those n's don't have the same power, therefore they can't be combined. Any others? Anyone want to throw up a polynomial here? Lucas, what do you got?
10z minus 4n plus 5w plus 6a.
Keep going.
Yes. Yeah, you could continue on, I suppose, 4 or more. So, or just something, like A plus B plus C plus D plus E plus F, right? That would be a 6-termed expression, but also a polynomial. Questions on any of these terms or yes? Well, we are multiplying here, like the 7x, it's not written, but it's 7 times x. Multiplying doesn't break a term. Multiplying keeps the term together. So when you multiply something, it's part of the same term. Yes? You could, and we'll get to that down in the second section here. Yes? So division, if you've got division, notice how I wrote this 1/2 there. If I had written n cubed xz divided by 2, that expression is the same thing as I have here. So in that situation, you would make that coefficient a 1/2 rather than have it divided by 2, if you're going to write it in standard form the way that we are here. So division kind of being the opposite of multiplication, there are other ways to work around it. But obviously having a 1/2 here is fine. So it's okay to divide a term together, but we kind of want to write it as multiplication rather than division like this. Okay, good questions. Anything else? All right, let's get down to the fun part. As if this wasn't fun enough. Okay, steps to write a polynomial in what's called standard form. We saw standard form in the context of graphing in algebra. Here we see standard form in the context of graphing parabolas, which, like I said, we're not there yet, but this is kind of the start of it. So this is standard form for parabolas. Step 1, we want to combine all like terms. So this goes back to Julia's question earlier, if they have the same variable to the same power, can we combine them? And the answer is yes. I want to look at the first one in the second row here as an example. 7n to the 4th plus 13n squared minus 10 plus 8n squared. What are our like terms in this expression? Lucas. 13n squared and 8n squared. Good. 13n squared and 8n squared. And combining like terms is a lot like adding or subtracting fractions, in that with fractions, remember, you need those common denominators, and when you do your addition or subtraction, the denominator doesn't change. Same kind of thing here. You need those like terms, and when you combine these, the variable and the power don't change. So whatever n squared is, whatever value, whatever object, whatever it is, we have 13 of them. We get 8 more of them. How many do we have in all? Sorry? 21. So these terms would combine to be 21n squared. The variable and the exponent don't change, similar to when we add and subtract fractions. They have to be the same and they stay the same. Okay, so step 1, combine all like terms. We can't do anything else here. The 3 terms that we have are 7n to the 4th, negative 10, and 21n squared. Step 2 then is write the terms in order of greatest to least exponents. And we'll add something on that in a little bit, but for right now, greatest to least exponent. So all the 3 terms we have remaining, what would come first? Elise. 7n to the 4th, followed by Julia. And are we adding 21n squared or subtracting? Is that a positive 21 or negative 21? Positive. So positive or plus 21n squared. And then last, that constant always ends up last on everything. Minus 10, right? And so that would be our simplified nomial, which now that we've simplified it, we can classify it. What type of nomial is it? Mono, bi, tri, or poly? Soybe? It is a trinomial. Okay. Yeah.
So is that like always our
And for this objective, you need to classify it. You won't. I mean, if you're asked to write, yes, that'll always be your answer for this objective, where you need to simplify it, write it in standard form, and then classify it. Okay. Let's go over to the last one in the top row here. 7y minus 3x plus 12x minus 2y. What's a pair of like terms that I can combine here? Erica. 7y and negative 2y. And that sign's important because how does a 7y and a negative 2y combine? What do we get? 5y. Okay, 5y. And then what else? What else we got? That negative 3x and that positive 12x. What do they combine to be? 9x. Positive 9x. Where people do get tripped up here is with signs. Okay. Negative 3 plus 12 is positive 9. Why don't we use opposite operations here? And like add 3x to quote unquote both sides. Because there isn't a second side, right? There's no equal sign, right? We only use opposite operations when we move something from one side of the equation to the other. This is not an equation. There's no equal sign. So combining like terms, you take them as they are. Negative 3 plus 12 gives us positive 9. Yes?
You think we should order from the greatest to the least, but 9 is greater than...
I did say we should order from greatest to least. I also said we're going to add something on here, more. So it's greatest to least exponents, which the exponents here are both a 1. It's y to the first and x to the first. So when that happens, we look to our variables and we write them in alphabetical order. Okay, so look at the powers first, least to greatest. If they're the same, like they are here, we would write it in alphabetical order by variables, 9x plus 5y. Okay, because last time I checked, x came before y in the alphabet. All right. And what kind of nomial is this? Mono, bi, tri, or poly? Anybody? Binomial. Okay, so that's your task for CO42. I hope you think it is, oh, that's kind of easier than I thought it was going to be. That's not too bad. Okay, but where you'll get tripped up if you're not paying attention is with those signs. Okay, negative signs come into play. Any others you want to talk about here that you've come across that look particularly fun? Yes.
The last one in the middle row.
The last one in the middle row. This 2n squared plus 5n.
Yeah.
Okay. So Lucas wants to talk about this one here. 2n squared plus 5n to the fourth minus 8n plus 4n cubed plus 10. Are there any terms we can combine there? Any like terms? No. They're all a whole bunch of n's, but none the same power. So now we just have to look at it and say, well, I've got a power of 4, so my 5n to the fourth is going to go first. Then I've got a power of 3, so that's going to go next. Then my power of 2. That 8n, if the power is 1, we don't have to write it. Just like any other time there's a 1, right? Minus 8n, that would come next. And then our constants comes last. So 5n to the fourth plus 4n cubed plus 2n squared minus 8n plus 10. It's a heck of an answer, isn't it? And we can't combine anything. That's in the simplest form and in standard form as well. So your homework is to finish the page, which you've got half a dozen left to do or so, and we'll talk about it tomorrow. Anything else? Yes, Elise. Yeah, kind of crazy, isn't it? I'm going to erase this. So if you, oh, and back to this one here, mono, bi, tri, poly. Poly. It's 4 or more. Elise wants to talk about the last one, or the first one in the last row. And what stands out to you about that one, Elise? Yeah. Let's start with this 12n to the 7th here. If I start with 12n to the 7th, whatever that is, and I subtract 10 of them, and then I subtract 2 more, how many n to the 7th do I have left? 0. And if I have 0 n to the 7th, do I need to include that in my final answer? No, because there's nothing there. So it turns out these all cancel out completely. And then you look at your 4n to the 9th, and I've got a negative 4n to the 9th here, a positive 4n to the 9th there. What happens with those? They also give us 0 as a coefficient, which means they're completely gone. And so finally, it's the constant's time to shine. All that's left in that huge expression to start with is 6. So mono, bi, tri, or poly? Mono. It's a single term expression. And this is what really started to pique my interest in math when I was sitting in your seat back in algebra. Any value that you plug in for n in that expression, every single time, no matter what you plug in, what will the value of the expression be? 6, right? It's kind of disguised in all of that. You know, that no matter what you plug in, it's all going to cancel out, just leave you with that 6. I found that rather amazing. Okay. Does that help? Good? All right. The rest you can do on your own. Do tomorrow. You got about 5 minutes now, so you could finish up in class. That'd be great. With gusto, that's how you math.